Hey everyone, welcome to today's Explainer. As a senior technical architect, I'm here today to tear down a massive structural flaw in modern system design. Right now, almost every enterprise out there is rushing to build generative AI applications. But in that huge rush, most engineering teams are completely bypassing a foundational piece of infrastructure. It's causing silent failures, bloated costs, and a massive security blind spot. So today, we're going to fix that by looking at the missing layer, the AI gateway.
Okay, let's dive into this. Here's our roadmap. First, we'll identify the missing architectural layer. Second, we'll enter the AI gateway. Third, the enterprise control plane. Fourth, stopping AI technical debt. And finally, the new AI architecture.
All right, part one, the missing architectural layer.
So if you're an engineer currently grappling with integrating generative AI, I want to challenge you to critically evaluate your current systems right this second. When you look at your architecture and your data flows, what foundational piece are you currently overlooking? You've got your front end, your back end, your databases, and now LLMs. But how are they all actually connecting?
Well, for most organizations, it's just this incredibly fragmented state. You have application A making a direct, totally uncontrolled API call to OpenAI. Application B is hard-coded to talk to Google Gemini. Application C is trying to route to local models. It is pure chaos. Every single application in your enterprise is managing its own API keys and direct connections, totally bypassing any sort of centralized governance. It's the Wild West of system design, and quite frankly, it's an architect's nightmare.
Moving on to part two, enter the AI gateway. So the crucial point is that we have to insert an AI gateway. Think of this as the tightly controlled entry point for your entire enterprise AI ecosystem. If you're familiar with how an API gateway manages traffic for traditional microservices, well, this is exactly that, but purpose-built for the unique demands of artificial intelligence. Instead of your apps talking directly to a dozen different LLM providers, they talk to the gateway. It's that simple.
And this brilliantly illustrates the macro view of the system. On the consumption side, you have web apps, mobile apps, agents, and internal systems. Instead of completely bypassing your security perimeter, all of the requests flow straight into the AI gateway. This gateway sits right in the middle, acting as the ultimate traffic cop. It handles model routing, security, cost management, observability, reliability, and your specific AI policies. And then, and only then, does the gateway forward the request to the models and providers, whether that's OpenAI, Azure, Anthropic, Gemini, or your own local private models. The overarching mandate here is absolutely crucial. Centralize, secure, optimize, and observe. You are finally bringing control, intelligence, and governance to every single AI request in your enterprise.
Okay, part three, the enterprise control plane.
Let's systematically break down what this control plane actually does. The capabilities of an AI gateway really fall into 6 core features. First up, model routing. It dynamically chooses the right model based on cost, latency, context size, and availability. Second, security and governance. This one is huge. It centralizes authentication, authorization, and PII protection so you don't leak sensitive data, along with prompt filtering and strict tenant isolation. Third, cost management. You can finally track token consumption and measure your actual cost per application, per agent, or per tenant. Fourth is observability. You're capturing prompt and response latency, errors, timeouts, and AI quality metrics. Fifth, reliability. Think failovers between models if a provider goes down, retry policies, rate limiting, and circuit breakers. And finally, number 6, AI-specific policies.
Let's look a bit closer at those intelligent routing policies, because this is really where the gateway shines. It applies dynamic rules based on intent and task complexity. If a user submits a super simple query, the gateway automatically routes it to a small, fast, cheap model. But if the prompt requires complex reasoning, boom, it routes it to a massive, state-of-the-art large model. If the prompt contains sensitive internal data, the gateway detects that and routes it straight to an enterprise private model. Repeated queries get instantly served from a semantic cache to save on tokens. Knowledge queries are routed to your RAG pipelines, and multi-step tasks are handed off to autonomous agents. The gateway is making all of these intelligent decisions on the fly, totally abstracted away from the front-end application.
Next up, part 4, stopping AI technical debt. Look, the harsh reality is this. Without a centralized AI gateway, you are actively building massive AI technical debt. When we design enterprise systems without centralization, we are basically choosing to create unmanageable, sprawling dependencies that will inevitably break down.
Just imagine an enterprise with 10 different AI applications, 20-plus autonomous agents, and a dozen RAG pipelines. If they aren't using a gateway, every single one of those teams is redundantly implementing their own authentication. They're all writing custom code for model selection. They're all independently coding retries and failovers. They're all trying to figure out semantic caching, setting their own rate limits, building custom dashboards for cost tracking, and trying to duct tape observability and guardrails together. Guys, it is a complete waste of engineering hours. You are literally paying dozens of developers to redundantly solve infrastructure problems instead of building actual business value. The Gateway centralizes all of this, so your feature teams simply don't have to worry about it.
Finally, Part 5, the new AI architecture. Let's move to the overarching evolution here and see how this builds from what we already know. In our traditional architecture, we had the client, which talked to an API gateway, routing to various microservices. That was the standard for a decade. But think about the emerging AI architecture. Now the client talks to the API gateway, which routes to the AI gateway, which then intelligently delegates to your agents, your RAG pipelines, and your foundational models. The AI gateway, combined with a model router, observability, and governance, is fast becoming the undeniable bedrock of the enterprise AI platform.
Now, what's really interesting about this is the idea that the AI gateway may become to AI what the API gateway became to microservices. Think about that for a second. You wouldn't dream of deploying a sprawling microservices architecture today without an API gateway to manage the traffic, secure the endpoints, and handle the load, right? No way. In that exact same vein, deploying generative AI applications across an enterprise without an AI gateway is very quickly going to be seen as an architectural anti-pattern. The future enterprise stack isn't just about picking the smartest LLM, it's about having the right infrastructure wrapping that LLM.
Which leaves us with a critical question to consider as we look to the future of system design. Will the standalone AI gateway become the absolute gold standard for enterprise architecture? Or will the major cloud providers eventually just bake all this routing, caching, and governance directly into their own managed services, rendering a separate gateway unnecessary? It's a massive debate, and one that will probably define the next 5 years of infrastructure engineering. I hope this explainer gave you the architectural blueprints you need to evaluate your own systems. Happy learning!